Piecewise graphs you've actually seen before. You learnt them last year when you were doing 1.3, the graphing thing, and it's about having a graph that's made up of pieces. That's what it means. So there's two sorts of assessments we can have for graphs. One is where we're modelling situations using graphs, and one is where we are using graphs to, again, model something that's got pieces of it. So you might model like a skyline using a graph. So you might say, okay, there's a parabola. Oh, then there looks like there's a bit of a cubic going on, and then we might have an exponential for a little while or whatever like that. So as we go across the sky, we'd have little bits and pieces to go with it. So what you have to do, what a piecewise graph means is that you have to actually be able to dedicate a certain part of the graph by making the domain between two things. All right, so we talked about this when we introduced the domain ages ago. So you might get a graph like this. All right, so just some random thing that's been drawn to represent something you've been given. And a piecewise graph means we need to cut it up. So we want to cut it up as though each piece belongs to a graph. So what can you see in the first one? A parabola. Good. So we cut here and say, okay, at -3, this is a parabola. All right, what next? An absolute value to here. So until we get to 2, we've got an absolute value. All right, next. Cubic. And last, an exponential. Okay, so we've got 4 different parts that have been rolled up over the period of the graph. So the first thing we'd do is we'd say they're domains, so what we've cut them up into. So the first part we've got from -8 through to -3. So -8 through to -3 is our parabola. That means we don't have to worry about anything further out than just that piece. So again, for the absolute value, we're going between -3 and 2. All right, for the cubic, we're going between 2 and 7. And then 7 to 8. All right, so that's the period of what each one is. Now we have to try and find out what their equations are. All right, so we don't know an awful lot about them. We're going to say that this one was supposed to be symmetrical. Would be lovely if I drew it beautifully. So just draw it again here. Right. So what particular equation will be used for this one?
Y equals K x minus a bracket.
Good. We're going to use the x minus a bracket one. This one?
Y equals K, and then those lines. X.
Good. No squared, it's absolute value. Yep, next one.
Y equals K. And then the 3 brackets.
Where do we start? CA. X minus D, X minus E. And the last one? Exponential means that X is in the... So good. Right? So we've now got our equations. All right? Now we've just got to find the real ones for each separate thing. We actually only have to get 2 of these right with the domains to be able to pass the assessment. All right? So if we have a look at the first one, we're going to make it up. It's all right though. We're going to say this point here is 4 and this point here is 8. Okay? So we've got, I'm going to go over here and call this 1, 2, 3, and 4. So 1. All right, we've got what? A equals?
A equals
What's A? Good, -5.5. Well done, guys. And B?
4.
4. And K is what we have to find. All right, so we're going to use what point for K?
-3.
Okay, we've got -3/8 as our extra point. So we put this into our formula, y equals K, -3 minus 5.5 squared plus 4. So we've got 4 equals -8.5 squared. Quick, somebody, -8.5 squared. $72.25 K equals 4. So our K here is revolting, and it's likely to be in a real world. It's not likely to be 2 or 3. All right, so revolting's okay. We just put it back in our equation. So we've got 4 over 72.25 x minus 5.5 or 5.5 squared plus 4. 1 mark. Not quite. We also will probably be asked to name features. We only have to name a couple of them. Tell me the features. For this graph, what have we got? The vertex, good. And we know that is at -5.5, 4. What else? One more thing. Axis symmetry, and that's at x equals 5.5. Remember, got to be an equation. Right, so that's 1 tick for our achieve, done. Second one. Okay, we're going to say that this is at about 1, -3. Who knows if it's right or not, but yeah, we're just going to pretend that it is right, because I haven't actually sussed these out first. So number 2, we've got A equals 1, B equals, and our point let's use the 0, 2, because it looks easiest. We've probably got 2, and that's my problem, is that the 2 might not match because I made it up. So y equals K, absolute value x minus 1 minus 3. 2 equals K, -1 minus 3. 5 equals K. What happens to this -1? Becomes positive, so 5 equals K. Y equals 5, x minus 1 minus 3. If I put -3 in here, what do I get? -4, +4, 20, minus 3. Oh, it's way off on the 8, but that's okay. So what features have we got here? Axis symmetry at x equals 1, good. And vertex 1, -3. X-intercepts 0, 2, 0, and 0, 0, which means the y-intercept is also at 0, 0, which is where my problem lies in my graph. That's okay. Good point. Let's go back and redo that. 2 minus 1 is what? 0. 3. So we've actually ended up with 3. Wonder if it'll work now. Let's try it out and see. So if we put -3 in, we've got -4 times 3 is 12, minus 3 is 9. Really close now to my picture, thank you, but still not perfect. But yeah, okay, good picking up. Put you on my list. 3. What kind of graph? Cubic, right, all done. So we've got C is 2, D is, we haven't said, let's just pretend it's 4, and E is 7. Okay. It's actually not, but it's just before 7, but that's okay. We're going to pretend it's 7. So, and we have another point? No, we don't. Shall we make a point? Sure, why not? Let's say that this point at 3 is at 3, just to find our K. So we've got another point, 3, 3, right? So we go Y equals K, X minus 2, X minus 4, X minus 7. All right? We want to find 3 equals K. 3 minus 2 is 1. 3 minus 4 is -1. 3 minus 7 is -4. Times those all together and we get 4K. So K equals 3/4. Y equals 3/4. X minus 2, X minus 4, X minus 7. Features? X-intercepts are 2, 0, 4, 0, 7, 0. What else? What other one thing could we say about it? It's a positive cubic. Not much else we can say because the other things happen off the graph. That leaves us with one more. We'll move over here to do it, which is our exponential. All right, what do we need to look for an exponential? Where it goes through 1. Let's make 9 over here. We don't want an equal sign on it. We're just going to go with that being at 8. All right. So we're going to say that that's 1 up above because we want to find that point that's 1 out, right? So that's our axis there. What is A and B?
A is 8.
A is 8.
B is 2. 1.
Or 0. Right? It's going to be 1 up from that B.
Oh.
Okay? And then we've got this point here, which is 9, 8. But we actually don't need to know that because we know we've gone 1 out and 8 up. So K is going to be 8. So we've got Y equals 8, X minus 8. What do we have here for features?
Asymptote.
Good. Asymptote is at where? Y equals 0. Good stuff.